Good morning, everyone. My name is Francisco Lopez. We're Team 984. I'm accompanied today by
Travis McKinney.
I'm Eric Sanders. I'm going to be doing the RF coding and the RF design for this project.
Daniel Del Nero, Power Management.
Modus main software engineer.
Brett Friedheim, circuit design.
So today we're going to tell you about IRIS, which is the Intelligent Radar Implemented System. Before I talk about it, though, I do want to do a little activity with y'all. If you guys could take a few seconds and close your eyes. I want you to imagine that you're walking in your neighborhood on your way to maybe a store, and you have no sight. And all you hear are cars zooming by, you hear vehicles everywhere, and you have no idea where you are. And let's say you reach a road. What are you going to do? Well, that's why I want to present to you guys IRIS. You may open your eyes now. So this goes beyond further than just maybe people who have visual impairments. This can also apply to maybe your children walking to school. They need to go to elementary school, they need to cross the road. To elderly, maybe your parents. They might not have the best hearing or sight. And you want these people to be safe. These are people you care about. So how walkable is your community is really what I'm trying to reach out to. Currently, 30% of crosswalks do not have any accessibility for visually impaired. That's why we decided to implement or create the IRIS. So IRIS is a very cool system. It uses the radar, an OPS 243C, which can sense velocity, direction, and a range up to 100 meters. And we will also be using ELP cameras to detect pedestrians. The way the system works is divided into two parts. The main part is the cameras and the radar, which will be used to detect pedestrians using YOLO v3 software and Python on a Jetson Nano. And essentially we'll be calculating to see whether there's a pedestrian on the crosswalk, and then detecting vehicles and how far they are and at what velocity they're traveling to detect whether it's safe for a pedestrian to cross. Now, the second component of this project is that we are also creating a wireless communication system that will communicate between a receiver that the pedestrian will have, this is for the visually impaired, for the elderly, for the child, and the transmitter on the actual IRIS system. Essentially, when it is safe to walk or it's not safe to walk, it will be sending out a signal to the receiver, which will be on the child's backpack, on the visually impaired's purse, whatever the object is, but they will have some sort of keychain that will give haptic feedback and report to the pedestrian whether it is safe or not safe to walk. Now, we want to make this device also usable for people who have no issues, right? To make the environment safer. So we will also be adding LED lights on our system to kind of signal like a go for green for go and red for stop type of system. So some of the goals that we have are to create a clear communication between pedestrians and drivers, because that's something that current systems lack. Also, one thing that current systems have is that they're actually very expensive. They cost $1,100 just to get the simple pedestrian walking man LED sign. So that's a lot of money, plus you need the actual traffic light post for that to operate. Ours does not require that. Ours can be set up on a simple post and will be very easy to implement in any crosswalk. Currently, we are looking at an ideal environment where it's only 2 lanes going back and forth. We're not working with an actual 4-way intersection, but that is one of our stretch goals. We also want to make this thing last for more than 12 hours so it can operate during daylight hours when your kids would be going to school, when most people would be out and about. Now, this system is also very easily adaptable. We're trying to make it as easy to modify so we can keep adding onto it. We want to make it solar powered in the future, have technology so that it can regenerate battery life. We are currently using a battery source that can hold up to 28,000 milliamp hours of power, which will give us plenty of lifetime. And so with this device, we are looking to create a safer community, assist elderly, assist visually impaired, assist children, and also just implement them in places where they can be needed, such as cities, campuses, and other important places. And that is our device. Any questions?
So the sensor, is that a Doppler sensor?
It is actually a radar sensor. There was an OPS 243A, and that's the Doppler sensor, but we decided to go with the C because it has more capabilities. It does have, like I said, the velocity, distance, and the direction.
Do you have a cost objective?
Yes, so we are trying to keep it underneath $1,100 to be more cost efficient than what we currently have in technology. Currently, we are reaching that goal. We have actually cost reduced from our previous options. We have already cut our costs down by 50%.
Do you have any fail-safe mechanism? Like you are saying successfully crossed 90% of pedestrians.
What happens to the other 10%?
Yes.
Turn
Like I said, this is a prototype, but we are implementing in our algorithms some sort of like emergency warning. Let's say a car doesn't want to stop, for example. We throw the stop signal and the car doesn't listen. We do have a fail-safe in our algorithms to tell pedestrians with like quick and ease that, hey, you got to get off the road immediately. Even if it's last second, it's something to tell them, hey, the driver didn't listen or some sort of error happened.
Is the battery for loss of power outage, or I wasn't clear on the battery?
So this is operating without a direct power source. It's going to be operating on purely batteries. Like I said, we do want to implement the solar power just because we can have that running all the time.
Yeah, and that's most of those traffic signs run with solar power.
Mhm. Yes.
Also, when you say easy to implement, what's your metric going to be? That's a very generic metric.
So-
From your setup times. Yeah.
Great question. The really cool thing about this system that we're implementing is that it's going to be on a chassis, and we can essentially put it up wherever we want. Currently, for technology, we want to use that crosswalks. They have to implement the whole traffic light post or some sort of expensive equipment that's wired directly to the ground, some sort of power. Ours is actually going to be very mobile. We can take it off, put it on a tripod if we want to, just test it out at a crosswalk, and then if we want to make it implemented, just put a post and put it down.
But those light posts have municipal regulations for many, many reasons, like a car hitting it and many other things. So when you say it's easy to implement,
Mhm.
how long can it endure, or what you probably need to think about what the implementation is besides the tripod.
That's a good point. Thank you.